Hey families, hopefully this video is distraction free and it gets to you guys and it's not super confusing. I really want to make a video that will help you guys, help your student work on double digit division. Double digit in the sense of two digits out here in the divisor. Um, in fifth grade we work with division of numbers with two digits in the divisor for the first time. So students, this can often be a difficult concept for them because their multiplication fact goes up to, or basic facts go up to 9. Some kids have 10, 11, and 12, but the majority of our students are, working on 1 times 1 to 9 times 9. With that said, in class we took opportunities to look at this in visual models and different strategies of reasonableness and estimation. This that I'm showing you tonight is just the algorithm. Some parents like to call this the old school method of solving, and but in this old school method, there's good conversation to have with students. I'm going to just put something here. A good conversation to have with students about the concept of the divisor in a division problem. Our divisor is our multiple understanding. So what I mean by that is students, when they're asking the question, does 12 go into 3,619? What we're asking with this quotient up here is what multiple of 12 equals 3,619. That's a very obscure question mathematically. It's just so abstract that it doesn't really make any sense to ask a student that. So we break it down bit by bit. Students find out that they can list their multiples over here. That's what I started doing: 12, 24, 36, 48, 60, 72, 84, 96, and 108. They can list 9 multiples of the divisor over here, and this will help them in breaking this question down into manageable chunks. So they start out with a 3, okay, and they say, is there a multiple of 12 I can put up here in this box that is less than or equal to 3? And already I've had so many students make the connection that no, anytime, Mr. V, we have a 2-digit divisor, it cannot be less than a 1-digit number, talking about just the 3. So I was excited when a lot of the students made that connection. So they automatically know there's not anything they can put up there. So now we're going to talk about the 36, okay? So now we're looking at the 3 and the 6. We're excluding the 19 for right now. We're just not, it still matters in the problem, but we're not worrying about it. We're saying with 3,600, can I share those 3,600s to 12 people? Or is there a multiple over here in my multiples column? Is there a multiple of 12 that's equal to or really, really close but less than 36? Well, the first multiple would work, but if I put the first multiple and subtracted 12, I would have something bigger than the divisor left over, and that wouldn't work. Let me undo that. The second multiple, the same thing would happen. I would have something, I would have 12 left over, and that'd be equal to the divisor, so that wouldn't work. If I use the third multiple of 12, that's 36, and if I subtract that out, I'm left with nothing there. So I've dealt with the 3,600. Now I'm going to look at the 110, and I'm going to bring that down. And I'm going to say, if I had 110, can I share it to 12 people? Well, with 110, you can't share it to 12 people evenly. Or, looking at our multiples list over here, there isn't a multiple of 12 that I can put up here and say blank times 12 is less than 1. So I say no. There isn't a multiple of 12 that's less than 1. So now how about this 9? Let me bring this 9 down. Because instead of looking at it as 1, 10, and 9 ones, I'll say 19. If I had 19 ones, well, yeah, I can share one, at least one, to each of the 12 people. I would share them, and I would have 7 left over. So this remainder of 7 is less than my divisor of 12, and the students would find, well, I got 301 with a remainder of 7. How do they check that back? I taught the students, and many of them made this connection, that if I take the quotient, 301, and multiply it by 12, the divisor, I should get the the dividend in here of 3,619. We'll talk about this remainder here in 1 second. So then they use their understanding of the standard algorithm for multiplication, and our students are pros at this by now. I'm not even taking the time to even talk it out, because they can do this almost with their eyes closed. Well, Mr. V, wait a minute. You said if I do 301 times 12, I'll get 3,619, and I only got 3,612. Well, the remainder 7, you have to add the remainder of 7 here, and now we will see 7, 8, 9, drink the 1 down, the 6 down, the 3 down. If I add the remainder on, I in fact get... Hopefully that last example wasn't terribly confusing. Case in point, to divide multi-digit numbers, the students have to, let's use something like this, and we'll go just random numbers in here, okay? The students have to first list the multiples of the divisor. They got to list out the multiples of their divisor. And this is good practice for the students to do. Just keep working with arithmetic with numbers. So they take their divisor of 11, and this one will be easy for them. They do 11, 22, 33, 44, 55, 66, 77, 88, 99. They do 9 multiples of the divisor. And then I've taught them to multiply, subtract, bring down. So there's their checklist, if you will. So they start off with list the multiples of the divisor, and then they checklist it. Okay? So if they have listed their multiples, they start out with the first digit here. They know it's a big old nope. I can't do something times 11 to be less than 2. But with 26 here, with 26, the first multiple works, and the second multiple works. The third multiple does not. 33 is bigger than 26. So the second multiple of 11 is 22. Let me erase this line so it's not confusing. I subtract that out. 6 take away 2 is 4. 2 take away 2 is 0. So we multiplied, we subtracted, and now we bring down, and they just bring down the next digit, the 7. And students get into the point where they cross these out when they've used them, just to help keep them, keep them in check, keep them organized. So now we're asking what multiple of 11 is less than or equal to 47. Well, the first one works. The second multiple works. The third multiple works. The fourth one works, but the fifth one does not. So the fourth multiple, or 4 multiplied by 11, is 44. I subtracted, I'm left with 3 here. I've subtracted. Now I got to bring down. Bring down the 8. I'm done with that. And now which multiple of of 11 works with 38? Or which multiple of 11 can I subtract from 38? The first one works. The second one works. The third one works because it's 33, but the fourth one does not because 44 is larger than 38. So I put the third multiple here, and 3 times 11 is 33, and 8 take away 3 is 5, and 3 take away 3 is nothing. This number here, what I'm left with, is smaller than my divisor here, so it's a remainder of 5 up top. Students make a connection that they can multiply this with this and add the remainder, so they can do 243 times 11, find that answer, and then do plus 5, and they should get 2678. They should get 2678. They should get their dividend. So let's check it. 243 times 11. 1 times 3 is 3. 4, 2. And x there's 0. 3, 4, 2. Add them up. 7, 6, 2. And then they take 2,673 plus our remainder of 5, and voila, 5 plus 3 is 8, 7, 6, 2, and 2678, right up there. Hopefully this helps you guys and just at least gives you all something to work off of